Good morning, students. Welcome to the Masters course. Today we will start one new chapter, that is gas liquid contacting equipments. That is chapter 5. And today will be lecture 20. Still now what we have studied, these are the basic of mass transfer processes. Now time has come to apply the fundamental principles of mass transfer to design our mass transfer equipment so that we will get the desired separation as per need of the industry. Before going to the conventional mass transfer operation processes like absorption, distillation, leaching, humidification, drying, it will be good if we get some overview of the mass transfer equipments. Then it will be easy for us to explain the remaining thing. So in this chapter we will try to discuss about the mechanical design of different equipments and how it works, how does it look like. So equipments and devices for mass transfer are as follows. So we know that gas liquid or vapor liquid contact, okay, and with this thing there are four categories. One is gas absorption and scraping, distillation, humidification and dehumidification. Actually, in gas liquid or vapor liquid contact, and there is a vapor liquid or gas liquid contact in mass transfer, then there number of varieties are there. Different types of mass transfer equipments, and that's why if you see that chapter is gas liquid contacting, they did not tell that this is the equipments for mass transfer. But remaining 2, 3 and 4, that is liquid contacting, that is extraction, gas solid, drying and adsorption, solid liquid, leaching, crystallization, etc. They are also equipments. But if you take that solvent nectar, liquid. Here the vessel will be, that is the equipment will be nothing but a one cylindrical vessel. Whatever we calculate what is the volume of this vessel should be, let's check from the calculation we got. For liquid extraction we need that 20 meter cube vessel. So what we will do, we will give the 30% extra of this, because in a equipment if it fully we cannot make the operation. So always that operation, what will be operative volume, that will be 30%, around 70% of the total volume. So whatever we'll calculate the volume required for this liquid extraction, we'll just design 30% extra, and that vessel will be nothing but a one cylindrical vessel with impeller. So these similarly for gas solid or liquid solid, leaching, all these things are very similar. So here calculation in vessel, okay, or mass transfer equipment will be nothing but a cylindrical vessel with impeller, and whatever calculation we will get from our theory, just will make 30% of our design of that's all. But in case of gas liquid or vapor, like gas absorption, distillation, humidification, watering, these are the varieties are there. Lot of varieties are there. And that's why in this chapter is named as gas liquid contacting, because remaining for remaining 3, 2, 3, 4 points, that equipment will be nothing but a one cylindrical vessel with equal. But but in case of gas liquid, it will be different varieties are there. Okay, possibilities are there. That's why the chapter name is like this. Now, the gas liquid contacting equipment we consider. So, what is my aim? I want maximum mass transfer. And now from chapter 4, we know Na equal to capital K Y YAB star, or in terms of Kx, okay, capital Kx XAB star minus XCB, okay, overall mass transfer either in gas phase basis or liquid phase. I can calculate the flux. Okay. But in design, the rate is important. Rate is, what is rate? Rate is nothing but what is the flux into area. Now flux for a particular system, when you take the particular gas, particular solute, okay, and particular solvent, then your that and particular flow rate, then almost this Na is fixed, because the overall mass transfer coefficient will be fixed, and what are the concentration for a particular system, that will be also fixed. Now, how, if I can increase the area of the mass transfer equipment, then I will get the high rate. If I get the high rate, then I can able to make better separation with smaller equipment. Same concept if you see in reaction engine. If rate is high, then you will get the high conversion in lower volume of rate. Here also concept is set. Now in mass transfer equipment is designed in such a way so that I will get the higher mass transfer area. Because Na for a particular system, when flow rates and other things are generally, it will be almost fixed. You cannot change much. It is not in your hand. So the Na will be almost fixed. Okay. Now I have to look that to increase the, how I can increase the A. Okay. Now if you take the simplest gas liquid contacting equipment, that is Fouling fluid contact. What is this? So this is nothing but a one cylindrical vessel. Okay, cylindrical pipe is there. Okay. Then let's take, you have a gas, 10% ammonia, you want to absorb through water. So what I will do, from the top I will put the liquid water, it will come down from here, and from the bottom I will put the gas. Okay, and then this is the area where gas and liquid will be in contact, and then ammonia will diffuse from gas phase to liquid phase. Okay. So this is the mass transfer is happening. Now here, if you 10% ammonia, okay, and liquid is 0, and if the flow rate of gas and liquid is fixed, okay, and you cannot make the liquid and flow rate and too high. Generally, in gas flow rate 1 meter per second, you cannot go beyond this, because then pressure drop will be so high, then your system will not be very good. So liquid flow rate generally 0.5 meter. This is the typical values per second. You cannot, if you go beyond that, you cannot. So if these are the flow rates maximum, then you understand that your and other things are fixed, whatever the system you have taken, accordingly your the mass transfer coefficients will fix, and these are also almost 10%. This is the problem statement. This thing will be already. Now here, if you see, the mass transfer area is this one, this circular one. Okay, so 2 pi r into L. Very good. This is the mass. So this is the way you can make the absorption of ammonia from air to water. Because your flux is almost fixed, and what is the area, accordingly you will get the rate, and accordingly you will get the what is the height of this column. And here you can understand the area, that interfacial area, that is liquid and gas, this is very. So there is a, can we increase this area, can we make some modification in the equipment so that I will get the better surface area? This is my aim. Now if you take this, instead of this, if I do like this, another thing is, I take the pool of liquid and I will parse the gas. So once I will parse the gas, that lot of bubbles will be there. So, and these bubbles will move from bottom to top, and always this bubble will be contact with liquid. So there will be much more different. So each bubble has a surface area. Accordingly, you will get the surface. So in this case, if you calculate, if you can make large number of small bubbles, and here you can, if you make the calculation, you will find out you can increase the surface area in a significant. So in the previous one, it was continuous flow. Okay, this is gas and liquid was coming. Only thing was this was the area. Now if you put like this, second thing, so then you will get the better surface area. So this is one, this is some modification. But here also, if you see, this is a continuous flow, you can reach one up to a single liquid. This is called bubble flow. Now the next concept is coming. Instead of single equilibrium, here if I take one tray column or plate column is what? This is one tray. Okay, so liquid is coming from here, and gas is coming from this hole. Then liquid is falling down here. Okay, that's in the second tray. Then liquid is moving in this direction. Okay, and gas is coming from the bottom. Then it is coming down here, liquid. So liquid flow rate is like this. Okay, this is cross current on side this. And if you gas, so here as we discussed in previously, here we are making the multiple steps. We are reaching multiple equilibrium. So instead of this, if I make like this, then I will get the better separation. So this, you see, instead of weighted wall column, this one weighted wall column, this is the simple. And in your laboratory experiment, okay, you have to determine the mass transfer coefficient of this equipment. Okay, in your lab, this weighted wall column is there. This is called weighted wall column. So column is there. So accordingly, things are coming. So it is much modification. We are increasing the area, and as well as we are doing more number of equilibrium steps. Now another thing is spray tower. Spray tower is what? I will purge the gas from the bottom, and from the top I will purge the liquid. So there will be a contact between, because both are purging. Okay, so there will be some contact between gas. So if whatever the gas liquid contact area will be available, accordingly the mass transfer will happen. But instead of doing this, if we make some packing material here and I put the liquid from the top, and this distributor, liquid distributor, and this is the packing material, okay, and this is the packing material will be supported through a grid, okay. So then gas will move from bottom, gas will, inlet is there, gas is coming from this direction and liquid. So one column, okay. So here if you make this column, you will that, and if you put this packed bed, okay, packing material, then your area will increase. That you know already from your fluid dynamics knowledge. So because one, let's say, spherical ball, so accordingly in the spherical ball, liquid will come down, creep will come down through the spherical ball and gas will come. So there will be better mass transfer area, okay, because interfacial area. So once I will collect this one again second, then I will put another part. So liquid is coming, then another again purger is there and packed bed is there. So here I will get the better separation, and this is called the pack tower. But keep it in mind, in pack tower I can reach to a single, because it is continuous. So gas is coming from the top and this is coming like this. If you see in chapter 4, I told generally in mass transfer equipment, two types of, in gas liquid contact, two types are generally used. One is either packed bed or pack tower, and another is tray or plate column. Either this one, this is in general tray column or plate column, another is pack. So in gas liquid contacting equipment, generally two things are generally used, either tray or plate column. Okay. Just like I'm giving the example, distillation of petroleum crude, then separation of ethanol water, separation of ethylene, propylene, all are through tray column distillation. And packed bed also used in some cases, okay, vessel absorption of ammonia. Packed bed is enough, because if you use ethanol amine, it has a high affinity to absorb. So in this case, the packed bed is sufficient. Both the equipments have some merits and demerits, but these are the two equipments. One is tray or plate column, and is pack tower. This is widely used in gas liquid contact equipment in industry. In industry generally, 99% cases they are using either packed bed or pack tower or tray or plate. Now how does it look? You see, this I have given, okay, gas inlet, it is going outlet, and this is demister pattern, so that no fog or some, when gas is coming up, then it can carry some liquid, but it should not come out. So if there is a demister, so it will be, then liquid will come down, or there is foam, should not come, okay, demister, then liquid inlet, then liquid distributor, this is the packing material, then this is the support of packed bed, okay. Packing material will come in detail later, don't worry. Then this is again from this packed bed, we collect the liquid, then distributor, then again packed bed, this is and liquid. And if you see the three-dimensional view of this one, this is the fluid dimension. So this is the gas inlet, gas will come from bottom, it will come out here. Okay, then liquid inlet here, then liquid distributor. So there is one distribution. So because it will spray what is packing, and this is the packing material. So if this is packing material, so liquid will come side of the packing material and gas will come side by side, so there will be gas liquid contacting area I am increasing. Instead, if I don't put this packing material, that area will be very less. But if I put this packing material, that will be, then I will get that. Then there will be another challenge. What type of packing material I should use so that I will get the mass transfer area as high as possible. That will also we have to look. So from this it is coming, okay, then it is collecting here, okay, then again liquid distributor. So this is the thing, this is the 3-dimensional. So if you see, this is the 2-dimensional to understand, but if when this is to industry, then you will see, but this is the, I cut it, but when you will see in industry, but you will see the all are insulated, you will like to the only pipeline and vessel, but what is inside you won't able to see unless the plant is under maintenance or equipment is under maintenance. So then you have to imagine what things are there, what I have studied. Accordingly, you have to predict the lines, all these things. Okay, and this is the plate column. So plate column, how does it look like? This is different parts. One is top part. So here I am putting the feed. Let's take the example of distillation of petroleum crude. So what I do, I put the petroleum crude with some heating, and it is a gas liquid mixture. Okay, not always, it is not there that it is not necessary it will be only vapor. It can be the gas liquid mixture or liquid even. Then what will it will come down, okay, and once it will come down, there is one reboiler. Reboiler means this is heating. Okay, so let's say this is the bottom product is coming out. So I will take this bottom product as this, and some bottom product, reboiler nothing but a one heat exchanger. What is the bottom product is there? With steam I will heat it in a higher way, and then it will put it again. A part of products I will put into the column with excess heat here. So then if it is excess heat, then what will happen? Whatever the low boiling material or high volatile material, so they will strip off because of this, and that's why it is called stripping section. So what are the feed line? It is not always necessary you will put the feed line here. When I will feed line here, when I don't need any heating, but sometimes in plate column heating is required. Just I told the petroleum, the distillation, separation of petroleum crude into different parts: LPG, naphtha, kerosene, diesel, lube oils, all these things. So here you need some heating, but if you want to make it, let's take, want to absorb ammonia from gas mixture to water, then you don't need reboiler. Okay, if you don't need the reboiler, then you can put the gas stream from the bottom and liquid from the top. But when you need to heat this one, then the reboiler concept it is, then you cannot put the feed bottom, so you have to put the feed someone up. So whatever the all high, because in separation, okay, in distillation, my low boiling will come as a top product. Let's take here, it will come LPG, then kerosene, all these things, and diesel, all these things will come at the bottom. Or let's take, I put ethanol water mixture. So ethanol has a low boiling point, it will come as a top product, and water has a high boiling point, it will come as a bottom. But here I am putting the liquid or vapor liquid mixture, water and ethanol. If I put this one, so whatever the ethanol, I have to strip off. How will if I use a reboiler and if we heat this one, then more ethanol will generate from this bottom section, will be stripped off and it will go to the upper phase. This section is called stripping sections. So stripping section, it is done through the deboiler. Then this is the bottom. Then what will happen? Then high volatile component or more low boiling component, more will be come to the top as a top product. Okay. And when we will catch a gas, now I want to condense. Condenser is nothing but another heat exchanger. But here that you should use, here you are using steam, here you use the cold water. So then it will, the vapor will come to the liquid, then you separate and take as a overhead product. And what I will do, I will part of this top product I will put as a reflux. Why I will put the reflux? Because this is the purest product and this is the top tray. So in the top tray, if I keep the purest product almost, then whatever things will come, it will be also pure. So to make this one, to make surety of the grading of the product, we put some reflux. So this is the typical plate column design. And you will see during distillation, in distillation generally, this is the general concept we use. And if you see the three-dimensional view, it is like this. Okay. So feed is somewhere. Okay, it depends on that. What is the fraction of vapor? If fraction of vapor is high, then it will be down, and fraction of vapor is low, then it will be somewhat up. Okay. So these are the trays. Okay. These are the different trays. Three-dimensional trays are there. Then overhead it is condenser. Okay. Then distillate and some liquid from the condenser. I am putting here some as a reflux, and here I am taking bottom product. Okay, some bottom product and some what I am with the deboiler I am putting it. So this is the plate column. This because it is multi-stage, different plates are inside the column, and pack column means packing material is there. But you should understand, in packing material single equilibrium can be attained, but in a plate column you can attain multiple equilibrium stages. Now, what are the advantages and disadvantages of different types of column? Let's take first one, the packed bed. Used more often for absorption, distillation of vapor liquid mixture. Generally, first style should be generally packed bed. If packed bed works, then people go for the packed bed. If packed bed is not economic, then people go for the generally tray column. The liquid flows downwards through the packing and the vapors flows upward. What is advantage? It is cost efficient, very easy, because if you want to make so many plates, okay, then your construction will be very high. But if you have only cylindrical vessel, then you put the machinery, then cost will be. And here in this case, pressure drop is lower. Although you know that in packing material is pressure drop will be there, but it is this pressure drop is lower compared to your tray column. Good for thermally sensitive look. Which liquid are generally thermally sensitive. In general, tray column generally it is famous for distillation, but it can be done for other process. And generally there will be heating. So if there is one sensitive liquid is there, heat sensor, then it will break up. So this is good. And what is disadvantage? Packing can break during installation. Packing, you have to periodically you can change this packing. And second thing is important from theory we understand, that is single equilibrium. In tray, number of trays or stages is dependent. Okay, advantage cost efficient, cost efficient, can handle high liquid flow rates and gas flow rates. In general, when liquid flow rate and gas flow rates are very high, then you cannot go for packed bed. Because if you go in packed bed, when the liquid and gas are flowing through this packing material, their superficial velocity will increase very high. So you need a very high diameter column to maintain this. But in case of tray column, liquid or gas flow rate will not change much within the column, because there is no, it is they are almost free type of thing. And generally when production is low or gas and liquid flow rate is low, it will go for the packed. But when the production is very high, let's take petroleum production, you need tons of petroleum, tons of diesel, all these things, very high flow, very high demand. So then if your demand is high, that means your flow rates will be high. If flow rates are higher, generally that tray column is advantage. What is the disadvantage? It has high pressure drop than the pack. Because here when it is coming, because liquid hole up there, when gas is bubbling through this, here the pressure drop will be higher than the pack. And here another thing is mechanical problem, that hubbing can occur due to agitation. And foam will occur. So let's talk today. In next lecture, we'll see more detail of plate column or tray column and pack. But here in today's class, we understand that for gas liquid contacting equipment, although there are a number of things, but generally either pack bed or tray column are important. And in 99% cases in industry, it has been used. Thank you for your attention. Have a nice day.